We are going to talk about binary operations on sets. A binary operation operates on two elements in a set, resulting in an element of that set. It operates on only two elements at a time, hence binary. Remember that in mathematics, a set is a well-defined collection of objects. The objects in the set can either simply be listed or they can be described. We are going to use objects instead of numbers to look at the underlying concepts in algebra. We will start with this simple set of three elements. The binary operation will take two of them at a time and operate on them, resulting in a third element. We will look at the rules that are going to govern how the binary operation acts on this set. We're going to use this asterisk, or star, as a symbol for our binary operation. However, this does not mean multiplication. It's just a set of rules where you take two elements as an input, and it produces an element as an output. In this case, when you have this binary operation operate on blue and red, it produces yellow. Another way to write this is as blue star red equals yellow. Remember, this star does not stand for multiplication. You can't multiply colors, it wouldn't make sense. We're just using the star as a symbol to represent the pure binary operation we're talking about here. These are the rules for the binary operation operating on the set. In particular, the operation assigns every two elements in the set to one other element in the set in only one way. There's going to be an identity element. Every element will have an inverse. It might be commutative, but it will certainly be associative. You don't actually have to know what these rules mean yet. We're going to introduce that later on. But just to get you used to the vocabulary, we set it up here. When you've got a limited number of elements for your binary operation, it's possible to represent every single possible combination of inputs on a table, like this one. You're used to tables like this. We have them for multiplication and addition, but the general version of this table is called a Cayley table, where you can have it be for any operation that you can think of. Here's a Cayley table for our star operation and the three colors. You can read it by saying, for instance, if we want to know what the combination of yellow and red are, then you find yellow on the left, and then you find red on the top, and then you draw, down and to the right until your fingers meet, and you find red. So, if you do yellow, star, red, that means the output is red. You can see from the table that yellow, when starred with anything else, ends up being the same. This means that yellow is the identity element for this binary operation. Think about it as being like 1 is for multiplication. Anything multiplied by 1 equals that thing. Or like 0 is for addition. Anything plus 0 equals that same thing. Note that yellow isn't inherently an identity element. It's only an identity element for this particular binary operation. You can think about it the way that 1 isn't inherently an identity element. It's only an identity element for multiplication. So even though we associate identity as being an attribute of the element, it's really an attribute of the element and the binary operation. Once you have identified the identity element, you can find each element's inverse. The inverse of an element is what results in the identity element under star. For instance, if you want to take blue and get yellow, you star it with red. That means that the inverse of blue is red. You can easily use the Cayley table to find the inverse for any given element. Just look for the yellow in each particular row. Then when you follow the table up or to the left, you can see that those two elements must be inverses of each other. We know that yellow has to show up in each row because of the rule that every element must have an inverse. In multiplication, 1 is the identity element because 1 multiplied by anything is itself. We use the -1 exponent to mean inverse, just like in our example where blue inverse is red. we're ready to take a closer look at the rules by which a binary operation operates on elements in a set. The general rules are closure, associativity, identity, inverse, and commutativity. But remember that commutativity is optional. We read a Cayley table as left star top. So the left element is always first and the top element is always second. So if we look at this example, blue star red equals yellow. But with this particular binary operation, red star blue also equals yellow. This is because the table is commutative. The root word of commutative is commute, which means to travel. When the elements of the set can commute with the binary operation, it means that the order doesn't matter. You can move the elements around and the operation is still the same. Blue star red is the same as red star blue. The diagonal symmetry from the top left to the bottom right tells us that all of these elements commute and the order will never matter. Now let's talk about associativity. A binary operation is only defined for two elements at a time, hence binary. But what if you have three or more elements which are starred together? You have to get the results in steps, two at a time. Now whether or not it matters which two you do first tells you whether or not the binary operation is associative. For instance, here we can do blue star red and get the answer to that, and then do whatever that color is, star yellow, and then we could also do it as red star yellow and get the output of that, and then do blue star whatever that is. And if those two operations have the same result, then we know that this binary operation is associative. So if we go ahead and crunch through these examples, on the top one, first we do blue star red, which if we look at our table, blue star red equals yellow. So then we end up with yellow star yellow, which from our table is yellow, which means that the output of this entire top line is yellow. Now we go to the bottom line. First, this time we're going to do red star yellow, which, as we know, is red. And then we do blue star red, and we get yellow. So we end up with yellow for the bottom line as well. This means that, at least for these particular examples, they will have the same output. Usually, at some point in the past, some mathematicians will have gone through and checked every possible combination of element inputs for this binary operation to determine whether or not it's associative. This would take too long for you. Luckily, you get the benefit of other people having done this work for you. For instance, right now, I can just plain old tell you, this binary operation is indeed associative. So, how will you use this going forward? The concepts that we have talked about in this lesson are critical to algebra. If you understand these concepts, but without the context of a more familiar number system, then algebra will become easier for you to learn. Learning how to compute is possible without understanding the structure of the system, but it becomes much easier when you actually understand the underlying structure.